Good evening, everyone. Am I audible? Hello, am I audible? Just please
Yes,
confirm.
ma'am.
Yeah.
Audible only.
Okay. Thank you.
Good evening, ma'am.
Good evening. So, this is the week 6 of the online session, week 7 of the courses, but week 6 of the online session. So, I am Mansi Tripathi and TA for the course Water and Wastewater Treatment. So, as you are well aware that here we try to solve some questions that can help you with the assignments as well as that may help you with your examination. So, I guess you might have registered for the exam. So, these questions will help you there. Okay. So, we'll not delay much. We'll start. I'll share the screen, then we will start the questions. I'm in lab right now, so there might be some disturbance. So if there is anything that I'm not audible, please do tell me. Okay, I'll share my screen now. Okay. So as you know, this is week 6 of water and wastewater treatment. We have set of 11 questions that we will try to solve and try to be, if there are numerical questions, try to use calculator and solve it. It will be better if you can answer the questions before I show you the answer, so that you can match also, and we'll be able to understand if there is any problem you guys are facing. So the first question is, select the correct statement regarding phosphorus removal. So this week was mostly about the tertiary treatment. So these type of treatments are not required when we deal with some basic things. So tertiary treatments are required when we go for some advanced treatment or specific reuse application. Based upon the reuse application, we design the tertiary treatment. So tertiary treatment, phosphorus removal is one such tertiary treatment. So what are the correct statements regarding the phosphorus removal? Phosphorus removal efficiency improves if nitrate concentration is higher in wastewater during anaerobic stage. Phosphorus can be removed from wastewater by ferric chloride addition. Phosphorus uptake is there during the aerobic stage and released during anaerobic stage. Biological phosphorus removal is removed by promoting phosphorus accumulating organisms by providing them alternate anaerobic and aerobic condition in the treatment plant. So what can be the correct statement?
Ma'am, option B and D.
Okay, we'll see. So yes, very correct. Ferric chloride addition, but what will this ferric chloride addition will do? This will increase the amount of sludge. That is why we prefer biological treatment. So that is more cost effective. So biological treatment, we use different types of plants which has phosphorus or phosphorus accumulating organisms which has some luxury uptake. So if they need, for example, if they need zero point 0.03 grams of phosphorus, milligrams per liter of phosphorus, they will take some extra. Okay, so if they will take some extra, and after some time we will remove those organisms, then phosphorus will be removed from the water body. So they are more like, they won't degrade the phosphorus, they won't transform it, they will just accumulate it. Okay, so here phosphorus is not changed from one type to another, only accumulation takes place. Okay, so this is very important to understand. Phosphorus can be removed by accumulation or by precipitation. Precipitation is a little costly, so we go for accumulation. Second question is, hypochlorous acid is added for disinfection and deprotonates. It deprotonates as shown this equation. This is the K. The sum of HCl and OCl is known as free chlorine. Okay. It is given that there is 80% fraction of HCl in the free chlorine. What is the pH value of the solution? This is numerical question and it's very simple. You have to just tell, you have the pKa value, pH you need to calculate. You can use a well driven equation. So you can solve this question. So please try to answer this question, then we will see the answer, then you can match your answer with that. Okay, we'll see the solution now. So what is pKa? This is Ka values. K means association constant. So what is pKa? Negative log of Ka. So this is what we got. What is free chlorine? HCl plus OCl as given. What what is HCl? It is 80%. There is 80% fraction of HCl in the free chlorine. So HCl is, it is saying HCl by Fc is equal to 80%. So this is what it is written. I was talking about well-derived equation. So this is Henderson-Hasselbalch equation. So this equation you need to learn. Very important. Okay, so it is like pH is equal to pKa plus log there are many forms of equation. So this is salt, this is acid, or we can learn it like this also, pKa plus log A negative Ha. Okay, so H means this, A means this, and A negative you can see. So we can learn in this form also. So this is the form in the different forms by which you can learn this equation. So most common use of this equation is to prepare a buffer solution. When we want to prepare a buffer for anything, we use such equations. So when we will put this equation, when HCl is 0.8, what is OCl? 1 minus 0.8, 0.2 Fc. So this is what we got pH. Okay. Any doubt in this question? If there is any doubt, you can ask in between. Otherwise, we'll move forward. Next question is also a numerical type question. Here we have 40 mld wastewater plant. We have surface overflow rate. Okay, just note down the units. Units are very important. We know the recirculation ratio R. MLSS concentration also we know. We need to calculate the solid loading rate. SLR. What is SLR? Note down the unit. This is given in day. This is we have asked in hour. This is also in million liters day. So do the proper interconversion of units and try to solve this question. I'll give you a few minutes to do this. This is quite big question. Try to solve it.
Ma'am, is it 1.5625?
Okay, we'll check. Yes, very correct. Your answer is absolutely correct. So what is surface overflow rate? Is Q upon AS. So this is how we will get AS. AS means surface area. Which area? The top area, surface area. This is not the side area, remember, surface area. Then SLR is equal to Q plus QR means the flow which is coming reversed. So when the recirculation ratio is 0.5 means QR upon Q is equal to 0.5. So QR we need to find. Q is 40. So QR comes as 20. So this is what this is. Okay. So Q plus QR into X, okay, divided by AS, and taking care of the units to convert this thing to hours and all. That's multiplying by 24, and this is what we got. This is in kg per meter square per hour. So we'll move towards next question. What is the correct sequence of formation of following compounds during chlorination? Here we do chlorination. I hope you know this breakpoint chlorination. This is residual. This is dose. It should come like this, but it never comes like this. So it comes slightly like this. So why this happens? So there will be formation of various compounds at different stages. That's why we find this breakpoint chlorination. This is breakpoint chlorination. So what is the sequence of compounds that are formed when ammonia is present? Okay, remember this graph, one more equation is coming in this respect. So here we are just talking about when ammonia is present, what ammonium compounds are formed. But there are various other compounds that can be formed when we put chlorine in water. So you can answer the question. It's very easy, very simple. It's visible. Okay, we'll see the solution. So it's 2, 3, 1. What happens? When we add chlorine in, say in the form of HCl, it reacts with ammonia. So first, only one chlorine atom will come. So it will be NH2Cl. When more NaHCl reacts with NH2Cl, then one more chlorine atom will come. Then again HCl plus NHCl2 and Cl3. So all these compounds are possible, but which compound is dominating, which is not? So it depends upon the pH of the solution. Okay, there are pH range for which this will form or this will form or this will form. Mostly in the wastewater, NHCl2 will be more. Okay, moving towards next question. In a trickling filter system, the biomass at the interface of biofilm and the media surface undergoes. So, as you know, in the trickling filter, just imagine this is a media particle. So there will be a layer of biomass around it. Okay, so this is the layer of biomass. Some of the biomass is highly attached to the media and some are little far. So both of these biomass layer will undergo different condition. So what type of condition it may go? You can select the correct option. It can be aerobic, anaerobic, anaerobic, or exogenous or endogenous.
Ma'am, is it option B?
Okay, we'll check. Yes, your answer is very correct. Why? Because outside air is there. So the outer biomass will take up air and it will become aerobic. But the inner biomass, oxygen is coming from here. All the oxygen will be consumed in this area. Oxygen finished. So for inside there will be no oxygen. So that is why it will be anaerobic. Inside layer is anaerobic. And when it is in anaerobic condition, that is first thing. Second thing, we have some organic matter in the water. We have some nutrients in the water. Nutrients will also get consumed in this area. It won't go beyond this area. So what will happen? This inside area, there will be lack of nutrients also. So they will eat each other. So when the microorganisms or anything eats each other, what it is called? Endogenous respiration. Okay, so that is why the inside layer will have anaerobic as well as endogenous respiration. I hope you understood this concept. So this is applicable anywhere, wherever there is a biofilm formation. And after some time, what will happen? If these goes on, goes on, goes on, what will happen? There will be no more biomass to eat one another. So it will just come out of the media. Like it will just break and come out. That is what we call sloughing. Okay, so this will happen. Now the media will be separated from the biomass. It will just become dry. So same thing is written here at the biofilm and media interface. Anaerobic respiration happen which leads to sloughing of biomass. What is sloughing? Just this is the media. Biomass just will detach itself. It will just be removed. So that is sloughing. Coming to the next question, the disinfection efficiency of hypochlorous acid in treatment. I have already answered this question. Hope you can answer it very quickly. The efficiency of hypochlorous acid depends upon pH, increases with pH or decreases with pH, and whatever. See, you can see the options. You can answer the question. I'll give you a minute to think on it. Yes, Saf, you want to say something? Okay, I think it was by mistake. Yes, Saf, say. Your hand is raised. You can write in the chat box also. Okay, we'll see the solution for this question. So it decreases with increases pH values. Okay. So hypochlorous acid, what happens? Let's see this HOCl. It will dissociate to form H plus and OCl ion. So it will only dissociate in this direction. If we are increasing the pH value, it means we are increasing the H plus content. Oh, if we are increasing the pH value, it means we are decreasing the H plus content. Increasing the pH means just say pH is going from say 5 to 8. So H plus ion will decrease, right? Because it is negative log of H plus. So H plus content is decreasing. So reaction is moving towards this direction. More, see this, if this thing is decreasing, reaction will move towards right, correct? So OCl negative will increase. But what is the thing? OCl negative, any hypochlorite ion, is less efficient than HCl. That is why overall disinfection efficiency will decrease. The power of, let's say, power of HCl is more than power of OCl negative. But due to increase in pH, H plus is decreasing. So you know Le-Chatelet's principle, what will happen? The reaction will move towards right. When the reaction is moving towards right, more of OCl will form and power of OCl is less. That is why overall disinfection efficiency will decrease. So this is the principle for this question. Let's move towards next question. In a biological nitrogen removal process, we are removing nitrogen using biological means. Arrange them in order of their increasing nitrogen removal efficiency. This is a kind of a memory based question. So you have to remember these names and you should remember the sequence. So try to answer this question if you remember the sequence. Otherwise, you will see in few minutes the solution. Okay, we'll see the solution for this question. The sequence is 3142. So as I've told, this is more of memory based. So there is not much explanation. All these processes have their basic principle that you might have studied in your lab, in your course. So we'll move forward. An acid dissociates in water as below. Okay. Ha. I hope you remember that Heisenberg equation. I wrote na A negative by Ha in that form. So remember that equation in that form for this for solving this question. We have pKa values. The pH of the solution after addition of Ha is 4.2. The concentration of A negative at equilibrium is this much. If X is the total concentration of Ha in the solution at equilibrium, then X into 1000 is. So do not worry about X into 1000. First try to solve this question. First try to find out what is the total concentration of Ha. We know concentration of A negative. Everything we know. I'll write equation. pH is equal to pKa plus log A negative Ha. We have everything. Everything is there in front of you. You just have to put these values. So let's see. Try
Ma'am,
to
is
get
it
this.
1.148 in 10 power minus 3?
Okay, we'll see. You are very fast. We'll see. Yes, absolutely correct. Your answer is very correct. So we know everything. We know how much A negative is there. It's in equilibrium. So everything is in equilibrium. We know pH, we know pK. Just we have to put in the equation, and here we are getting with the solution. Ha, and question is multiply it by 1000, because what happens during the examination, computer will be checking your papers. So these type of questions, these type of numerical values, like everyone will not write like this, right? Some people can write like 0.00148. Okay, so it may create some confusion. That is why this is the best way to write such equation. Just multiply it by some bigger number so that you can get this absolute value. So it will make the task easier. So this was the only reason to multiply it by 1000. So while solving the question, please read the question properly. Just for your understanding, everything will be given very clearly. Just read the question properly. One more numerical question. This is based on Chicks-Watson law. For disinfection purpose, a concentration of 0.1 gram meter cube of free chlorine is applied, which yield 96% kill. That too in 7 minutes. First of all, this question is in two parts. Find out the contact time required to achieve 99% kill efficiency. So this is two parts. So first of all, we need to calculate one thing in the first part. That thing we will use for the second part to find out the contact time. Okay, so try to solve this question. It's based on Chicks-Watson law. I'll give you 2 minutes for that.
Ma'am, for
Yes.
99 percentage, T equal to 10.01 minutes.
Okay,
Is it correct, ma'am?
yes, I think it's correct. Yes, it's absolutely correct. So this is the Chicks law. Uh, and what is difference in when we say Chicks-Watson law? What will happen? There will be concentration here. There will be one more concentration term here. Then it will become Chicks-Watson law. Here it is just Chicks law. So this is the equation for the Chicks law. Everything is given. You have to just find out K in the first step. After finding out the K, you just have to put that K and you will see the solution. So this is second last question and a basic theoretical question. Select the correct statement regarding disinfection and its method. So here different types of disinfection methods are there: chlorination, ozonation, UV, chlorinamination. So you have to select the correct statement regarding the disinfection. Try to solve this question.
Ma'am, is it option E?
Okay, we'll see. Yes, correct, 100% correct. The disinfection, first option was the disinfection efficiency of chlorine increases by decreasing the contact time. So this is absolutely incorrect because if more bacteria, we have seen in the last question, right? In 7 minutes, 96% bacteria were dying, but in 10 minutes, 99% bacteria were dying. So first statement is absolutely wrong. During chlorination, only trihalomethanes and haloacetic acids can be formed as DPPs. So this is also wrong. Earlier, actually, we used to think that only these DPPs are forming. Okay, but later we realized that there are more DBPs. There are many nitrogenous DBPs also. Okay, that are more harmful than the normal carbonaceous DBPs. Okay, see is Ozone needs shorter contact time for range of pathogens and does not form harmful disinfection byproducts in the presence of bromide. So this is absolutely wrong. In the presence of bromide, it will form many inorganic disinfection byproducts. Okay, the disinfection byproducts are less than chlorine, but there are and they are very lethal. Option D is turbidity has no effect on UV removal efficiency. So that is not at all possible. See, when we are passing light, UV is light, right? So it should pass very nicely. If the water is turbid, what will happen? It will block the way. So there will be bacteria which will take shield in this turbid water. So there will be some effect. Option E is ozone is more lethal than UV in killing protozoa giardia. Yes, 100% true. So that is why option A was correct. Moving to our last question. So I have told you to remember that graph, breakpoint chlorination. So this is based on that only. So try to solve this question. We have to determine the sequence of various steps of breakpoint chlorination. We have to arrange them in sequence. Okay, since one of you has answered, so we will see the solution. So it's very correct. 3, 2, 1, 4. First, destruction of chlorine residual by reducing compound. Reducing compounds, there will be various compounds that we can reduce the chlorine. That can just use, they will just use the chlorine and go away. Next is formation of chloroorganic compounds and chloroamines. We have seen how chloroamines are formed. First is destruction of chloroamines and chloroorganic compounds. Whatever which was formed here will get destructed here. Fourth step is formation of prechlorine, means here. After some time, whatever we are giving, it will appear as such. Okay, so this was the last question. Is there anything to discuss? Shall we close the session now?
Okay, ma'am. Thank you. Thank you so much.
Okay, thank you so much. If there is any doubt in between, you can ask in the next session or you can just post in the forum, discussion forum. Okay, okay, I'll close the session now. Thank you, everyone.
Okay, ma'am. Thank you.